NASA detected a mysterious object speeding toward Earth.
So on October 3rd, 3IAtlas will pass within 29 million kilometers.
On the night of July 1st, 2025, astronomers at the Atlas Survey Telescope in Chile noticed something unusual. Their automated detection system, designed to catch fast-moving objects, flagged a faint point of light cutting across a crowded star field. At first, it looked like just another comet, but its speed immediately raised eyebrows relative to the Sun, far too fast for anything bound by our solar system's gravity. The more they observed, the clearer the picture became. Its orbit didn't form a closed loop like normal comets or asteroids. Instead, it followed a hyperbolic path, the mathematical signature of a true interstellar traveler. This meant the object wasn't born in the Kuiper Belt or Oort cloud. It came from another star system altogether, carrying with it the chemical fingerprints of a world we may never directly see. Almost immediately, the discovery began echoing across scientific communities. This wasn't just another comet. It was only the third confirmed interstellar object ever recorded, following the mysterious Oumuamua in 2017 and 2I Borisov in 2019. Each of those earlier visitors sparked debates and left behind unanswered questions. And now, 3IAtlas promised to do the same, possibly on an even greater scale. Its projected course brought more excitement. The comet would swing close to Mars on October 3, 2025, giving spacecraft orbiting the red planet a front-row seat to the action. Weeks later, on October 29th, it would reach perihelion, its closest approach to the Sun. This rare trajectory set the stage for a rush of global observation campaigns, as telescopes and mission teams scrambled to prepare. From the very beginning, 3IAtlas wasn't just another point of light in the sky. It was a messenger from another star system, a chance glimpse into a chemical environment billions of years and light-years away. And with every kilometer it traveled, anticipation grew for what secrets it might reveal. The countdown to 3IAtlas's arrival has been one of the most anticipated events in modern astronomy. Its journey through our solar system is brief, fast, and filled with high-stakes moments that give scientists only a narrow window to capture data before the comet vanishes back into the void. If you enjoyed this cosmic journey and want to help us keep exploring the mysteries of the universe, hit that subscribe button. Every click, like, and comment makes us happy and keeps us motivated to bring you even more amazing discoveries. On October 3rd, 2025, the comet will make its closest approach to Mars, sweeping just 29 million kilometers from the red planet. While that may sound like a vast distance, in astronomical terms it is incredibly close. Close enough for Mars-based orbiters like MAVEN and the Mars Reconnaissance Orbiter to get a clear, uninterrupted view. These spacecraft, originally designed to study Mars itself, are now being retasked to act as humanity's outpost for interstellar science. Their vantage point will prove critical because Earth's own observatories are about to face a serious obstacle. Just weeks later, on October 29, 2025, 3IAtlas will reach perihelion, its closest pass to the Sun. Normally, this is the prime moment when comets reveal their secrets, their icy cores erupting into brilliant tails under solar heating. But there's a problem. This timing puts the comet deep within the solar exclusion zones of both the Hubble Space Telescope and the James Webb Space Telescope. These flagship observatories cannot risk pointing so close to the Sun. The danger of permanent damage is too great. That means Earth's most powerful eyes will be forced to look away during the most important weeks of the comet's journey. Debate has raged within astronomy circles over whether an exception should be made, but in the end, safety protocols prevail. For many, it feels like a once-in-a-generation opportunity slipping out of reach. And yet, the story doesn't end there. With Mars trailing just inside the comet's path, its orbiters become our only hope of capturing real-time data during this crucial phase. In effect, Mars itself transforms into a science station for Earth, giving us the chance to glimpse an alien visitor when our own tools cannot. This alignment, first with Mars, then with the Sun, creates a fleeting but extraordinary opportunity. It ensures that, even as Earth's most advanced observatories sit in silence, humanity will still have eyes on 3IAtlas when the mystery burns. Brightest, the world first glimpsed something extraordinary on the night of September 7th, 2025, as a total lunar eclipse bathed the moon in a deep crimson hue. A handful of backyard astronomers pointed their telescopes toward the stars. What they captured would ignite a storm of speculation across the globe. In Austria, Michael Jürger snapped an image of 3IAtlas with what looked like a faint, icy blue haze surrounding it, a fairly ordinary sight for a comet. But only hours later, Gerald Raymond in Namibia posted his own image. To everyone's astonishment, the same object now glowed with a vivid emerald halo, stretching tens of thousands of kilometers from its core. Within minutes, the pictures spread across astronomy forums and social media, and disbelief gave way to awe. Comets sometimes glow green, but this wasn't normal. The usual culprit is dicarbon, or C2, a fragile molecule that fluoresces under sunlight and paints many comets with a ghostly green light. Yet here, the timing was wrong, the brightness too intense, and the hue itself unlike anything seen before. What's more, the shift had occurred almost overnight, with no precedent in the records of cometary behavior. Amateurs everywhere double-checked their cameras, filters, and calibration tools. They reprocessed data, compared notes, and confirmed the impossible. The green glow was real. Even as the eclipse ended and the moon left Earth's shadow, 3IAtlas remained locked in its emerald state. Professional astronomers scrambled to react. Emergency proposals went out to telescopes worldwide, requesting precious observing time. Spectrographs were aimed at the comet in hopes of decoding the glow. Yet the early data revealed a shocking twist. The expected fingerprints of dicarbon were completely missing. No swan bands, no trace of the molecule that should have explained the color. For the first time, humanity was watching an interstellar comet reveal an alien signature that didn't match the chemistry of our solar system. A simple night of stargazing had turned into a front-row seat to a mystery billions of years in the making. When spectrographs were finally trained on 3IAtlas, the results sent shockwaves through the scientific community. Comets from our own solar system almost always follow a predictable recipe. Water ice as the dominant ingredient, with smaller amounts of carbon dioxide, carbon monoxide, and various organics mixed in. But 3IAtlas shattered that expectation. The data showed an astonishing imbalance. Carbon dioxide outweighed water by nearly 8-to-1. This was no trivial deviation. It meant the comet's ices had been forged under conditions utterly foreign to the environments we know. Alongside the CO2 dominance, there were traces of cyanogen, or CN, a molecule infamous in cometary history for its discovery in the 19th century, when scientists feared comets might poison Earth's atmosphere. Even more intriguing was the detection of carbonyl sulfide, or COS, a compound rarely found in comets, but considered important in the chemistry of life. On Earth, COS plays a role in amino acid formation, the building blocks of proteins. This strange cocktail hinted at a birthplace far beyond the boundaries of our solar system. The high ratio of CO2 to water suggests that 3IAtlas condensed in a region well past another star's frost line, the invisible boundary where sunlight is too weak to keep water vapor from freezing solid. In our solar system, that's the domain of the Kuiper Belt and Oort cloud. But here, the ratios pointed to something even more extreme, an origin in a colder, darker realm orbiting an alien sun. Scientists immediately drew comparisons with Oumuamua and 2AI Borisov, the two interstellar visitors that came before. Each had raised questions about their chemistry and structure, but Atlas presented something far more concrete: a chemical fingerprint that simply didn't belong here. To planetary scientists and astrobiologists, this was a revelation. The comet wasn't just an icy wanderer, it was a frozen time capsule, carrying the raw ingredients of another planetary system across interstellar space. Every molecule detected was like a signature, a message from a star we may never identify. In a single sweep of spectroscopy, 3IAtlas had done something profound. It proved that the chemistry of planetary systems beyond our own can be radically different, and that fragments of those distant worlds can find their way here. As the chemical analysis deepened, another puzzle emerged, this time in the comet's metallic signature. Normally, comets in our solar system display a familiar balance between iron and nickel. Both are abundant elements, forged together in the hearts of ancient stars and dispersed across the galaxy. In fact, in most comets, the iron-to-nickel ratio mirrors what we see in meteorites and planetary cores. But 3IAtlas defied that rule. Spectrographs revealed unusually strong nickel emission lines glowing in the comet's spectrum, while iron was conspicuously absent, almost to the point of being non-existent. This imbalance made no sense. Iron should have been there, and in far greater abundance than nickel. The comet wasn't just chemically alien, it was metallurgically alien as well. Theories quickly emerged to explain the anomaly. One possibility is that the nickel wasn't free metal at all, but bound into organometallic compounds. Strange. Molecular hybrids where nickel atoms are locked together with carbon-based chains. These types of compounds don't naturally form in the warmer regions of our solar system, but in the deep freeze beyond another star's frost line, they could be stable for billions of years. Such chemistry points to an environment colder than anything Earth has ever known. Temperatures so low that exotic ices and metallic complexes could form, survive, and remain trapped until a passing gravitational nudge flung the comet into interstellar space. If true, this would mean 3IAtlas carries within it the fingerprints of a world that operated under completely different rules of planetary chemistry. Where our comets are dominated by water and dust, this one may have been sculpted by the interplay of nickel-rich organics and cryogenic chemistry, unlike anything we've cataloged before. For scientists, the message was clear. The materials that shaped 3IAtlas didn't just come from another solar system, they may have come from a kind of planet-forming environment we've never even imagined. And with every spectrum recorded, the comet seemed to whisper the same truth. Our cosmic neighborhood is far more diverse and far stranger than we ever dared believe. As 3IAtlas moved closer to the Sun, astronomers turned to a subtle but powerful tool: polarimetry, the study of how light scatters when it bounces off dust grains. It's a method that can reveal the size, shape, and even the composition of the tiniest particles surrounding a comet. In 2024, during its inbound approach, polarimetric surveys returned results that stunned researchers. The comet displayed record-breaking, negative polarization, more extreme than anything ever observed in a solar system comet. Instead of scattering light in familiar, predictable ways, its dust behaved as though it were built from entirely different rules. To put this in perspective, comets typically fall within a known range of polarization values, like fingerprints shared across the solar family. But 3IAtlas broke that mold. Its readings didn't resemble comets at all. Instead, they looked more like the measurements taken of trans-Neptunian objects, those dark, frozen worlds that circle the Sun far beyond Pluto. Objects so cold and untouched that their surfaces preserve the most primitive materials in the solar system. This raised an unsettling question. Was 3I-Atlas more like a comet, or more like a fragment of a distant dwarf planet from another star system? The dust grains surrounding it seemed to suggest a history of compaction, alteration, and freezing unlike any comet we've studied before. The implications were staggering. If its dust matched the properties of trans-Neptunian objects, then the comet may have formed in an equally remote and frozen region around its parent star, a place where sunlight was weak, chemistry crawled. At glacial speeds, and exotic ices locked themselves into strange molecular structures. For astronomers, this was another reminder that 3I-Atlas wasn't just a comet. It was a time capsule from a frozen frontier, a drifting shard of a planetary nursery that may never have given rise to planets at all. The light bouncing off its dust carried whispers of alien worlds, encoded in patterns that even now scientists are racing to decode. One of the first questions astronomers asked about 3I-Atlas was deceptively simple. How big is it? Pinning down the size of a comet's nucleus is notoriously difficult because it's almost always buried beneath a shroud of gas and dust. In this case, the challenge was even greater. The comet's coma, dominated not by water vapor, but by carbon dioxide outgassing, was so dense that even advanced instruments struggled to see what lay within. Finally, with careful measurements, the Hubble Space Telescope placed an upper limit on the nucleus at no more than 2 kilometers across. By comet standards, that's compact, about the size of a small mountain. But what made it extraordinary was not its dimensions, but its resilience. To survive a journey across interstellar space, bombarded by cosmic radiation for untold eons, suggests that 3I-Atlas is made of materials far tougher and more unusual than those found in most solar system comets. And then came the most provocative insight. By comparing its chemistry, orbital stability, and radiation weathering, scientists began piecing together its possible origin story. The evidence pointed to a star system older than our Sun by at least 7 billion years. That means 3I-Atlas could have formed nearly 10 billion years ago, when the Milky Way itself was still young, and has been drifting between stars ever since. Imagine it. While our Sun was still a cloud of gas, while Earth itself had not yet coalesced, this comet was already old. Every molecule in its body is a relic of a cosmic age long before our own. Its surface carries scars from countless millennia adrift in the galaxy, frozen testimony to conditions no longer present in our corner of space. To look at 3I-Atlas, then, is to look into deep time, a fragment of a planetary system erased by the ages, still carrying the chemical DNA of a world older than ours. It is not just a comet, it is a survivor, a messenger from an epoch that predates the very history of our solar system. As 3I-Atlas speeds toward its closest encounters, a cruel twist of timing threatens to leave Earth's scientists blind. When the comet passes through its most dramatic phases, the geometry of the solar system conspires against us. For weeks, our most powerful space telescopes, Hubble and the James Webb Space Telescope, will be forced to look away, their instruments unable to safely aim near the blinding sun. Ground-based observatories face the same limitation, their view cut off during the crucial days around perihelion. In other words, during the comet's peak moment of activity, Earth itself will be effectively blindfolded. A once-in-a-lifetime interstellar visitor will be at its brightest, shedding the most clues about its origins, and our best tools won't be able to watch. But there is one saving grace: Mars. By sheer cosmic coincidence, the red planet lies near the path of 3I-Atlas's flyby. On October 3, 2025, the comet will swing just 29 million kilometers past Mars, close enough for its fleet of orbiters to take center stage. Spacecraft like the Mars Reconnaissance Orbiter, MAVEN, and even the ExoMars Trace Gas Orbiter are being retasked for an unprecedented mission to turn their cameras and spectrometers away from Mars itself and capture the interstellar wanderer. These probes, never designed for deep space comet studies, suddenly find themselves as humanity's only eyes during a blackout that stretches for nearly 6 weeks. This unusual role has transformed Mars into a scientific relay station, a forward base for interstellar exploration. While Earth's telescopes sit idle, the Red Planet's orbiters will be collecting the data that could define our understanding of alien chemistry, cometary evolution, and planetary system diversity across the galaxy. It's a reminder of how fragile our perspective really is. From Earth, even the grandest instruments can be silenced by simple geometry. But by spreading our presence across the solar system, we gain more than new worlds. We gain new vantage points on the universe itself. In October 2025, Mars will carry that responsibility for all of us. The story of 3IAtlas doesn't begin with its official discovery in July 2025. In fact, the comet had been silently recorded years earlier, hidden in plain sight, captured by telescopes whose data pipelines simply weren't looking for it. Back in 2023, NASA's TESS mission, scanning the sky for exoplanets, recorded countless images of stars in a fixed patch of space. Somewhere within that vast stream of data, 3IAtlas passed through, a faint moving point almost invisible against the background stars. The automated systems, designed to detect transiting planets rather than fast-moving interstellar objects, never flagged it. The comet slipped by unnoticed, leaving behind only digital footprints that would only be found after the fact. A year later, in May 2024, the Vera Rubin Observatory, still in its engineering phase, captured yet more frames of the comet. At this stage, the observatory was busy testing its instruments, and the enormous volume of data buried the comet's faint signature. It wasn't until researchers went back after the official discovery that these archival images were combed through, revealing the comet's earlier path with startling clarity. These near misses serve as a powerful lesson for astronomers. The cosmos is full of secrets, and even our most advanced surveys can overlook them if the search criteria are too narrow. The story of 3IAtlas highlights how new algorithms, real-time alerts, and refined detection methods are revolutionizing the hunt for interstellar objects. What once relied on chance observations by skilled eyes or serendipitous luck can now be systematically tracked and studied. Every faint detection, every archival frame, became part of a larger puzzle. By piecing these early images together, scientists not only confirmed the comet's trajectory, but also gained insights into its motion long before it became a bright green spectacle. In the era of 3IAtlas, the lesson is clear. To catch a visitor from another star, astronomers must look back as carefully as they look forward, because the cosmos rarely gives second chances. The arrival of 3IAtlas has done more than capture headlines. It has reshaped our understanding of planetary formation and the diversity of worlds beyond our solar system. Its unusual chemistry, dominated by carbon dioxide, rare cyanogen, and nickel-rich grains, defies the rules we have long relied on to describe how comets and planets form. Models that once used our own solar system as the template now need to account for alien conditions billions of years older than the Sun itself. Scientists are now looking to the future with urgency and ambition. The era of relying on chance discoveries is giving way to systematic, all-sky surveys designed to catch interstellar visitors as soon as they enter our solar system. Instruments like the Vera Rubin Observatory will scan the skies with unprecedented depth and speed, using advanced algorithms capable of flagging hyperbolic trajectories and unusual chemical signatures in real time. But detection is only the first step. Researchers are envisioning rapid response spacecraft, small, modular probes capable of launching on short notice. equipped to intercept and study interstellar comets up close. Concepts range from solar sail flyers to swarm missions that can split, adapt, and collect data on multiple targets simultaneously. The goal is nothing less than capturing the structure, chemistry, and history of alien worlds before they slip away forever. Atlas stands as proof that the galaxy is teeming with messengers from other stars, each carrying clues about the formation of planets and the chemistry of distant systems. Every anomaly, every unexpected signal, is a reminder that the universe is far more diverse and ancient than we have imagined. As astronomers refine their methods, the search for interstellar visitors will become not just reactive, but proactive, ensuring that humanity is ready for the next cosmic messenger. The story of 3IAtlas is not just a single event. It is the opening chapter in a new era of exploration, one that promises to reveal the hidden diversity of worlds across the galaxy, and, with it, the secrets of the universe's most ancient and exotic corners. If you enjoyed this cosmic journey and want to help us keep exploring the mysteries of the universe, hit that subscribe button. Every click, like, and comment makes us happy and keeps us motivated to bring you even more amazing discoveries.